Hello dear friends, I'm back with another question from the Harvard Entrance Examination Olympia. So friends, this was the question that you have on screen guys. The time allocation for this question was 2 minutes. You were expected to give the exact answer for this particular question. Okay, so guys, let's dive in. So friends, now that we are dealing with pairs, unidentical pairs, it's a good hint, and since the E function is included, it's a good hint for us to take the natural log on both sides. You do that, we're going to have the natural log of the left hand side equals the natural log of the right hand side. If we use the properties of the natural log function that we know by shifting the powers onto the front and knowing fully whether the natural log of E is simply 1, you're going to have E cubed ln x equal to x squared. Okay, now guys, you discover that at this point we have x squared, we have ln x, right? So it is a good hint for us to see that. But friends, guys, but firstly guys, you need to agree with me that this function in this case, since, let me ask you guys, is this our equation an even? Are all the functions here even? E raised by x squared, guys, is it even? Yes, it's even guys, but x e raised by, but x e cubed, is it an even function? No guys, it's an odd function. I noticed that the graph of this and this will intersect each other at just one point, okay? Just one point. So we expect to see just one solution for this particular equation. Even at this point where we simplify, guys, you see that you're going to see just one solution. But friends, I see that I have a mixture of x squared term and ln x, right? So it's a good hint for me to see that at the end of the day, I need to make use of the Lambert W function. So in this case, guys, I will try as much as possible to have an x squared term on this ln function. How can I achieve that, guys? I can only achieve that if I have what? If I can have a 2 in front. Because once I have that 2 or that negative 2, guys, I can simply bring it to the front, right? So I'll multiply top and bottom, guys, by negative. I'll multiply top and bottom here by 2, negative 2 specifically. I'll put the negative sign here, then put it here again. Because 2 and this they can cancel, this and this cancels, we have the same result, right? But friends, what am I going to do? What I'll do is that I'll simply carry this negative 2 from here to the front. Then first I multiply all through by 2. So this is what I'm going to have. So friends, at this point now, do you see that if I multiply all through by x to the power negative 2, I am going to have x to the power negative 2 on the left hand side. Natural log of x to the power negative 2 equal to what? Negative 2 e raised to the power minus 3 when I multiply again by e raised to the power negative 3. So this is what I'm going to have. So friends, at this point, I can look at this, my x to the power negative 2, and I write it as e raised to the power the natural log of negative 2, because these two guys, they can cancel and I have back the same expression as I had initially. So at this point now, friends, you notice that this, on the base we have ln x to the power negative 2, right? On the top we have ln x to the power negative 2. So great guys, we can use the Lambert W function at this point. If we do that, we have the W function of the left hand side equals that of the right hand side. So friends, at this point now, since this guy is the same as this, the output of this function simply becomes the natural log of x to the power negative 2 equals W of minus 2 e raised to the power negative 3. Great. So now guys, at this point now, do you see that we can take e to the power on both sides? We take the e to the power on both sides, we're going to have e raised to the power of x. We are going to have just x to the power negative 2 equals e raised to the power of this. But x to the power negative 2, guys, we can write that further as simply x squared equal to e raised to the power. We give the power a negative, we have e raised to the power negative w of that. So friends, you can try to simplify it, okay? This is what you're going to get. This is what you get. Keep in mind that when you take e on both sides, you're going to have both x to the power negative 2 and e to the positive power. If you must have x to the positive power here, the power of this guy has to be negative, right? So that's why we have the negative here. Then now guys, we have to take the square root on both sides, but let's be conscious that we will not take the negative, okay? The negative answer is not acceptable, okay? It is not acceptable. Great. So this is what we have, friends. So now this is where we take the square root, guys. We make use of the positive version. This is it. Now guys, this is simply the exact answer for this question. This was what the Olympia expected from you. Okay, this is it, because you are not using your calculator. This is it. But now, guys, you notice that if you go to Wolfram Alpha, guys, and you plug this in, you are going to have an answer of about 1.05722258. Okay, this is the approximate answer for this particular question. So friends, let me know in the comment section down below, guys, if you want more video like this. And friends, start by subscribing to the channel and liking the video, friends, sharing this video out with your friends so that they can have access to content like this, which is quite guaranteed to help them in their examination, friends. My name is Omenju Makarios, guys, a part-time mathematics and physics teacher at Step by Step School Complex, Bamenda. Have a blessed day.